Nice having you, my beloved scholars. JAM past question 2001, question number 5. And the question goes this way. If a spherical metal bulb of radius 3 cm, spherical like a football, metal bulb of radius 3 cm, is fully immersed in a cylinder containing water, and the water level rises by 1 cm, what is the radius of the cylinder? Okay. So the question targets to know the scholar's idea or understanding of Archimedes' principle. Archimedes' principle. An ancient scholar by name Archimedes taught the world how the volume of irregular bodies can be measured. It is very easy to measure volume of regular bodies by saying length times breadth times height. Okay, what if you have a body that has no length, breadth, and height? How do you measure? A good example is the crown of a king. The crown of a king comes in various designs, various architecture. So how do you measure the volume of such objects? Then you must bounce back to Archimedes' principles of measurement. Then Archimedes made us understand that to measure the volume of irregular solids, irregular bodies, that you get container, fill the container with water. Then measure the initial level of the water. I'm talking Archimedes. Measure the initial level of the water. Then now put the irregular solid inside the water. Then also measure the new water level. Then Archimedes says that the rise in the water volume is the same as the volume of the body immersed. Did you get the idea? See what we're saying? Get water in a beaker or in volumetric flask or measuring cylinder, pour the water, know the initial volume, the initial reading of the water in the container. Then when irregular body without a defined shape is immersed inside the container or inside the measuring cylinder, then the water will rise up. So the final level minus the initial level, whatever answer you have, is equal to the volume of that irregular body. Okay, let's see from the board. Okay, solution. So the question says cylinder. We'll draw a cylinder, then pour water inside. This is the initial level of the water. Initial level of the water. Then we get spherical bulb. Then immerse it. Recall the radius of that spherical bulb is 3 cm. 3 cm. Immediately you immerse the spherical bulb inside water, something will happen. The water level will never remain the same. It must rise to indicate that something is immersed. So it rises up. Let me use dotted line. So this is the rise in volume of water. Then, and the question says that rise is 1 cm. So anytime metallic bulb of radius 3 cm is immersed in measuring cylinder that contains water, the water level will rise by 1 cm. Now the question is now asking us, what is the radius of the cylinder itself? Then, you know, this is 2D. Cylinder is 3D. We should be having something of this nature. So this is our cylinder. So its own radius, let me use capital R, is what we're looking for. Then let me ask you, what did Archimedes say? Recall, Archimedes made mention of something. Archimedes says that the volume of the body immersed in the liquid, recall, the volume of the body immersed in the liquid is equal to the volume, the change in volume of the cylinder. Paying attention. Archimedes says the volume of the body immersed in that liquid, that body immersed, that metallic, that spherical bulb immersed in the liquid, its volume is equal to the volume, the change in volume of the cylinder is equal to the change that happened there. Is this bulb, this metallic bulb, that caused this change? Take this metallic bulb away, this change will go. So the volume here, the change in volume here is the same as the volume of this body immersed. That's Archimedes' idea. The volume of this immersed body is what brought about the volume here, the rise in volume here. So the question becomes, what is the volume of this shape, this sphere? the volume of sphere is 4 over 3 pi r cube. So that's the volume of the sphere. It's equal to, this sphere brought about this change. And what's that change there? Recall, liquid assumed the shape of the container. So what is containing that water? Cylinder. Therefore, this change here, we are concerned with this change because this body brought about that change and they are equal in terms of volume. So the liquid there will also take the shape of the container, and that container is cylinder. The question becomes, what is the volume of cylinder? Okay, that will be pi r square h. From your geometry, the volume of cylinder is pi r square h. But don't forget, we are just concerned with this fraction of change. Therefore, this h should be taking 1 cm and not the total height. Don't go for the total height. The spherical bulb brought about this change. So that's our concern. That's the equivalent. So let's solve. Okay, we have 4 over 3. Okay, notice, pi will cancel pi. Yeah, mathematically it's correct. Pi cancels what? Pi. So I'm now left with times. Then the radius of the spherical bulb, the radius is 3 cm. Notice this is also 1 cm. Therefore, we're not converting. Maintain the cm. So I have 3. The formula says you must put cube. Put the cube there. Equals. The radius we are looking for is this r. This is the radius of the cylinder. And that's what the question demands. So we'll keep it there. R square. Then we'll go ahead times the height that concerns this metallic bulb is this height we're talking about, 1 cm. 1. Then we'll forge ahead. 4 over 3 times 3 times 3 is 9. 9 times 3 we'll be having 27. Then r square. R square. Then observe. This over 1. Then 3 keys itself 1. 3 keys 27. We'll go back to what? 9. Then 4 times 9. Recall. Let's continue from here. We have r square is equal to 4 times 9. Recall, 4 times 10 is 40. Then minus 4. Then we're having 36. Then we're looking for r. The radius are not r square. Therefore, we'll square root both sides. Then square root of 36. We're having 6. Then check the units of other lengths there. We'll be having cm. Then going back to our option, we can see that the correct answer is option D. So in summary, the volume of any solid immersed in liquid is equal to the volume of the change that happens in the liquid. Paying attention. The volume of the body, one talks about solid, the other one talks about liquid. The volume of the solid immersed in liquid is equal to the volume of the change that happened in the level of the liquid. Archimedes. Thank you. Stay tuned as we go on with the mystifying jam pass questions.